This is a video demo for our final project, which is creating the Boids algorithm at a hardware level and making it very efficient. And this is done by Sean and Tate for EC350. And the goal of this project was essentially to build a hardware level implementation of the Boids algorithm, make it very fast, make it so that we can compute all the Boids in a parallel manner, almost like a GPU. And I'm going to provide a quick demo. So reset the FPGA. This is our FPGA, a Nexus A7, and we're using a VGA screen. So I'm going to reset it. And essentially what we have is a lot of Boids that are moving about, and they are essentially flocking. And we've added a few features to this algorithm. We can show the trail of these Boids over time, how they move, and you can see how they flock together. We've also created a dark mode. It sometimes makes them easier to see, and a freeze mode where we can freeze them. And these strobing effects are just a fault of the VGA. The code, as far as we know, is completely fine. So if we unfreeze, we can see these are the Boids. We've also implemented what we coined the scary Boid, which repels other Boids. And if I turn it to dark mode, hopefully this will be easier to see. And we essentially use a custom RAM for the display. Hence, we can actually increase the refresh rate and decrease it. But the increased refresh rate does cause some flickering because the VGA cannot actually keep up with it. And so it's just sometimes easier to see without that. That is our final project. And just to talk a little bit about how it was built, we've got it all documented on our GitHub, but essentially we started off by creating a Python simulation, and it looks a bit like this, where we took the Boids algorithm, removed any need of using multiplication or division by using funny ways of using hardware, AND gates, XORs, bit shifts, and all of that. And our goal was to recreate this, and this is our Python simulation of it. We converted it to C, then we used a custom compilation process to convert it from C to MIPS, but specifically MIPS for our own design of a 5-stage pipelined CPU that we made in Verilog from the ground up. And then we essentially started converting it into hardware, and our overall hardware overline, this is all in the documentation, looks a bit like this, where we've got a CPU that does all the computations, goes into some latched registers. We have a BP array that are built in a way we could have genuinely computed everything in parallel, and this would have made it much faster at the expense of using more FPGA space, more hardware, and so on. But the project specifications for this class needed us to use a CPU, so we essentially made it so that we could change some things very easily to make this all like a GPU computable thing. And we have kind of our design, our layout for how the logic and design would work in this document as well. But we included the CPU to comply with the class. And then we have our custom RAM, which allows us to do fast refreshes and essentially a double buffer kind of thing going on. And we have our VGA controller, which controls the screen, which is a bit funny. And this is all on our GitHub, where we describe all our components and future things, optimization, how we would implement the BPUs in parallel, and so on. Thank you.